Class 6 did a survey of the number of trees in a country park. This pie chart shows their results. Estimate the fraction of trees in the survey that are oak trees. So oak trees are represented by this section of the pie chart here. And I think you would probably need about 8 of these sections to fill the whole circle. So that means the fraction that are oak trees is 1/8. And you get the mark for an estimate of between 1/10 and 3/20. The children counted 60 ash trees. Use the pie chart to estimate the number of beech trees they counted. So ash trees are here, and we know that there are 60 ash trees. But we want to find the number of beech trees. Now we can see that the number of beech trees will be less than the number of ash trees because the section of the pie chart is smaller for beech than it is for ash. So if we take the section that's ash and then we move that, we can see that beech trees, there will be about 3/4 as many as there are ash trees. Because of the section that we now have outlined in red, about 3/4 of that is beech and 1/4 is not beech. So we can find 3/4 of 60. 60 divided by 4 is 15, and 15 times 3 is 45. Remember, finding a fraction of a number, we divide denominator, then times top. So I would estimate that there are 45 beech trees, and you get the mark for an estimate of between 40 and 50. You have to spot that there will be fewer beech trees than there are ash trees. Shade in the reflection of this shape. So to answer this question, what we need to do is count triangles from the mirror line. So here we can see that the triangle shaded is just above the mirror line, so we need to shade in the triangle just below. Now for this triangle here, we can see that from the mirror line, we go past a triangle and then shade. So going down from the mirror line, we go past a triangle and then shade. For this triangle here, from the mirror line, we go past a triangle and shade. So going the other way, going down, we go past a triangle and then shade. And then for our last shaded triangle, from the mirror line, we go past a triangle, past a shaded triangle, and then shade. So going down, we go past a triangle, past a shaded triangle, and then shade. So we've shaded the reflection of the shape. Look at these shapes. Complete the sentences below. So first, we need to find which of these shapes is a kite. Now remember, a kite will have a line of symmetry down the middle, and if we draw our line of symmetry on shape A, we can see that we have 2 longer sides and 2 shorter sides. We can also see that this angle here and this angle here are the same size, so A is a kite. And it might look more obviously a kite if you turn your page so that you have this bit on top. Now we need to find which shape is not a quadrilateral. A quadrilateral is a 4-sided shape because quad means 4. But if we look at our pentagon, if we look at shape F, we can see that it's a pentagon because it has 5 sides. So shape F is not a quadrilateral because it's a pentagon. It has 5 sides. Now, which shape has only 2 right angles? If we look at shape E, we have a right angle here and a right angle here. Because remember, a right angle is a 90-degree angle, which is the same size as the corner of a piece of paper or the corner of this screen. Now this angle here is an obtuse angle because that's larger than a right angle, and this angle here is an acute angle because that's smaller. So shape E has only 2 right angles. And now, which shape has 2 acute angles? Well, if we look at shape B, we have an acute angle So an angle less than 90 degrees, less than the corner of a piece of paper or the corner of a square. And this angle here is also an acute angle, also less than 90 degrees. We also have two obtuse angles in this shape, but because it has two acute angles, we know that shape B is what we need to write here. Here is a triangle on a square grid. The triangle is translated so that point A moves to point B. Draw the triangle in its new position. So translated means that the shape has been moved somewhere else, but it's been kept the same size. And the way to translate a shape is to count squares from one point to another. So to get from point A to point B, we can see that we go down one square and then 3 squares to the right. So we can do the same for our other corners as well. So here we go down 1 and then 3 to the right. So we'll have a corner here in our translated shape. And then for this corner, if we go down 1 and across 3, this corner will move to here. So then all we need to do is join up our points and we've translated our triangle. Circle all the multiples of 10. So remember, a multiple of 10 will be a number in the 10 times table, or a number that can be divided by 10 without giving a remainder. And all multiples of 10 end in a 0. So to circle the multiples of 10, all we need to do is to circle the numbers that end in a 0 and leave the numbers that don't end in a 0. This table shows information about 4 solid shapes. One has been done for you. So they've told us that a sphere has 0 flat surfaces and 1 curved surface. Because if we know that a sphere is like a football shape, we can see that there are no flat areas of this shape, it's just one large curved surface. Then, if we think of a cone, we have one flat surface because we have a flat circle on the bottom, and we have one curved surface because this surface here folds all the way around. Now, if we think of a cuboid, we have 6 flat surfaces because we have rectangles or squares as our surfaces, and we don't have any curved surfaces. And finally, we have a cylinder. So that's like a circle that's been stretched out. So we have a circle, a flat circle at the top, and a flat circle at the bottom. So that's 2 flat surfaces. And then we have one curved surface round the middle that curves all the way around the shape. So a cylinder has 2 flat surfaces and 1 curved surface. Write all the factors of 30, which are also factors of 20. So we need the common factors of 30 and 20. Remember, a factor of a number is a number that you can divide that number by without leaving a remainder. So first, let's find the factors of 20. It's useful to think of factors in pairs. So 1 times 20 is 20, which means that 1 and 20 are factors of 20. Remember, 1 and the number itself will always be factors of a number. Now, 2 times 10 is also 20, which means that 2 and 10 are factors. 3 is not a factor of 20 because we can't multiply 3 by any whole number to get 20. But 4 is a factor because 4 times 5 is 20. So 4 and 5 are factors as well. Now let's find the factors of 30. 1 and 30 will be factors because 1 times 30 is 30. 2 is a factor as well because 2 times 15 is 30. If we divide 30 by 2, we'll get 15. Or if we divide 30 by 15, we'll get 2. So 2 and 15 are also factors of 30. 3 is a factor because if we multiply 3 by 10, we get 30, so that's 3 and 10. 4 is not a factor because we can't multiply 4 by any whole number to get 30, but 5 is a factor because 5 times 6 is 30, so 5 and 6 are factors as well. Now we need to find the common factors because we need to write all the factors of 30, which are also factors of 20. We can see that 1, 2, 5 and 10 are factors of both 20 and 30. So the numbers we need to write are 1, 2, 5 and 10 because they're the common factors of 30 and 20. Circle the number that is closest to 20. So we need to find the difference between the numbers that we're given and 20. First, we have 19.95. That's 0.05 less than 20, because if we work out 20 minus 19.95, we will get 0.05. And we could do that using column subtraction, so we could remember that 20 is the same as 20.00, and if we subtracted 19.95, we would get 0.05. Or if we added 19.95 and 0.05, we would get 20.00, so that's 20. Now 20.1 is 0.1 more than 20. 19.09 is 0.91 less, because 9 and 91 make 100, so 9 hundredths and 91 hundredths make one extra whole, so 19 becomes 20. 20.09 is 0.09 more than 20, and 20.201 is 0.201 more than 20. So we need to work out which of these numbers is smallest, because that will give us the number that's closest to 20. Remember, it's easier to compare decimals if we write zeros on the end, so that all of the numbers we're looking at have the same number of decimal places. So because this number here has 3 decimal places, I've put zeros on the end of these numbers so that they all have 3 decimal places. And then it's easier to spot that 0.050 will be the smallest difference, which means that 19.95 is closest to 20, because the difference is only 0.05 and all of our other numbers have a greater difference. Now it might look like 0.1 is the smallest difference, but remember, this 1 is in our tenths. If we have 5 in our hundredths, that's less than having 1 in our tenths. So 0.05 is less than 0.1. Circle the value of the digit 9 in the number 697,432. So if we find the 9, we can see that it's in the 10,000s place, so it represents 90,000. It's in the 10,000s place, and 9 times 10,000 is 90,000. What we can do to find the value of a digit is to turn all of our other digits into zeros, and if we have 90000, then we have 90,000. Joe goes skating every Saturday. He went skating on Saturday, January the 1st. Altogether, how many times did Joe go skating in January? So we know that there are 31 days in January, and he went skating on January the 1st. Joe goes skating every Saturday, so that's every week, and a week is 7 days. So 1 plus 7 is 8, so he must have gone on the 8th as well. 8 plus 7 is 15. 15 plus 7 is 22. 22 plus 7 is 29, and 29 plus 7 is 36. But there are only 31 days in January, so we can ignore the 36th, and then we can see that we have 5 dates where Joe went skating. So he went 5 times in January. He went on January the 1st, the 8th, the 15th, the 22nd, and the 29th.